piece of Chapter 11, all statistics, we're going to talk about introduction to hypothesis testing. Okay, so a big part of what we're looking at today is, okay, how do we write these hypotheses representing these situations? And then how do we test? Because we're going to be writing 2 hypotheses per situation. Okay. Overall, the question that we are asking throughout this lesson is, how do you formulate and test a hypothesis using statistics? Okay, so as we look at situations, as I said, we'll be writing 2 hypotheses, kind of what the claim is and then just what the basic hypothesis is. Then how do we test? How do we know what's true? What are our options? So kind of goes in along with the others we've been doing in terms of, how can we test these situations? How can we try them out? Going from there. So let's look at example example 1, and we'll kind of work through some steps and talk about the hypotheses here. A car has been getting 34.6 miles per gallon. With a fuel additive, the car gets 35.5 miles per gallon. What hypotheses would you test to determine whether the increase in mileage is due to the additive? Okay, we've got 4 steps to kind of take us through this, because ultimately our job is going to be to write 2 hypotheses, which is the null hypothesis and the alternative hypothesis. You're going to hear those words a lot. We're going to work our way to that, though. Okay, so step 1, determine what your question means in terms of a parameter. So in terms of something that describes the population. So what is our situation here? Car's been getting 34.6 miles per gallon. With a fuel additive, the car gets 35.5 miles per gallon. Okay. What are we going to test to determine whether the increase in mileage is due to the additive? So what is the claim here? The assumption or the claim here is that with this fuel additive, what is happening? Yeah, the car is getting better gas mileage, right? More miles per gallon. And so what does this mean when we look at step 1? Basically, it's just kind of writing an understanding of the question. It's kind of what I think of it as. But how do we know the additive works? The additive works if the gas mileage is increasing, right? If the additive is not working, what's happening with the gas mileage? It's probably staying the same, right? Not increasing, in other words. Okay, so that's the situation we're looking at. The additive works if the gas mileage is increasing when it's used, and then the mean gas mileage, totally read that wrong. The additive works if the gas mileage is higher when the additive is used than the mean gas mileage when the additive is not used. Okay, so the idea, the additive is doing its job, right? So it works if the gas mileage is higher when it's used than when it's not. That's the basic gist. So I'm going to write that out here. The additive works when the gas mileage increases as the additive is used. Let's see. The additive works when the gas mileage increases as the additive is used. I think I might just leave it as that. The additive works when the gas mileage increases as the additive is used. Yeah, it's going to get too wordy and too confusing if I go farther. Okay. Now, we're being asked to state the information about the parameter mathematically. Okay, so we're going to put this into terms of, and all of this as we go through this, numbers, symbols, these are hypotheses that we're going to be writing. So what is the claim here? The claim is that our gas mileage is going to increase, right? So what is it going to increase? It's going to be greater than 34.6. And we talk about this, I'm going to use mu. I think I forgot to warn your class. Did you see mu in homework last night? No? Thought you did. I don't know. What does mu stand for? Do you remember? Go back to first half of the chapter before spring break. Mu is one way to express the mean. Okay, that's fancy little u there. And so if we use mu, the claim is that the mean is going to be increasing. It's going to be bigger than 34.6. And I'm going to go ahead and write this down. I'm going to say let mu equal the gas mileage, and I'm going to say with the additive. Okay, so the claim is that the average is going to increase if we're using the additive. Okay, so one of our hypotheses is that mu will be greater than 34.6. So the mean average will be greater than 34.6. That's if the additive is doing its job and changing things. Step 3. State what would happen if this hypothesis is not true. What's true about the gas mileage if the additive doesn't work? It stays the same, right? So our other hypothesis is that mu is 34.6. So one scenario here is that, okay, the additive, something is changing the average. The other is that, okay, the additive isn't really changing it. It's more of a by chance thing. Okay? So this is saying, I'll write it down in here. The additive does not increase gas mileage. Okay, so that's what the other hypothesis says. So two hypotheses. One is the claim that, okay, this additive is going to, it's going to be an outside variable. It's going to improve our gas mileage. The other is that my gas mileage isn't going to change. Any change is not due to the additive. It's just due to natural variation. Okay. So, step 4. Write our null and alternative hypotheses. Now, officially, we've already written them. It's what we just did on step 2 and 3. We just have to understand which is which. Okay, so let's see. I'm going to start with the null hypothesis. The null hypothesis, well, first of all, for what it will be represented as when they give it to you in homework and stuff is H sub 0. 0 being null is another way of, saying the beginning or 0. So H sub 0 is your null hypothesis representation. And in this case, the idea of the null hypothesis is, okay, if nothing changes, what are we already at? And so that is the idea of mu is equal to, the mean is equal to 34.6. So that is my null hypothesis. And that is the idea that, if you want the description out here, that there is no increase with the additive. Okay? If there's no increase with the additive, that's basically just saying that Any variation in that gas mileage is just due to natural variation. Okay? Maybe you had an extra windy day and the wind was pushing you from behind and increased your gas mileage. Maybe you drove more highway miles that day and increased your gas mileage. It was just from natural variation, but not the additive. That's your null hypothesis. The alternative hypothesis is based on something outside changing it, and that is the additive here. So null or alternative hypothesis. First of all, you will see it listed as H sub A standing for alternative here. So any type of notation you see in homework will be H sub A. And your alternative hypothesis is, okay, what is my claim here? If the additive is doing its job, what is the claim? And that was the one that the mean is greater than 34.6. And this one is the possibility of a difference due to the additive. It really went in the corner there. Okay. So alternative hypothesis is, okay, there's some type of outside source causing the change. In this case, it's so some type of possibility of difference. Something that is not just natural variation, that is changing it. So in this case, it would be the additive changing it. Null hypothesis is just that any change is not due to the additive. It is due to just natural variation. Okay? Now, as you look the next thing I have is a official definition of null hypothesis and alternative hypothesis. I keep repeating some of the same stuff, I know, but I'm trying to get the idea in your head. So officially, null hypothesis, H sub 0, as you see up there, the observed statistic is in a treatment group is equal to the corresponding population parameter, and any variation is due to chance. So right there, with a null hypothesis, any variation is due to chance. Okay, it's not due to an outside source such as the additive. Okay. Alternative hypothesis, H sub A, the observed statistic in a treatment group differs from the corresponding population parameter, and the variation is not due to chance alone. It's due to some outside source. In this case, that outside source being the additive. Okay? We're going to practice this some, as we work to identify our two hypotheses. This is something you'll have to do in homework. Now, in the homework, you won't be writing out these hypotheses. It'll be more of a multiple choice type problem. But they'll have, was there like 8 pairs on one problem where you're picking from? Okay, so if you can pick one of the hypotheses out, then the other is kind of the opposite. Okay? And we're gonna practice some. I'm gonna give you some examples here. Okay. A soccer goalie saved 46.4% of her opponent's tiebreaker attempts. After her coach adjusted her position in the goal, she saved 47.3% of the attempts. Write the null hypothesis and the alternative hypothesis for a statistical study to evaluate the population parameter P, which is the proportion of tiebreaker goals she saves after working with her coach. I do say they gave me P here, yes? So instead of using mu for the mean, which is what I was using last time, as we talked about the gas mileage, here we're going to be using P, which represents her proportion of saved goals. We need a null hypothesis and a alternative hypothesis. Almost, yes. Okay. So, and I know this one is a little bit different than the last one, but yes, to an extent. Okay. Right now, I don't know, maybe I should talk about alternative first, but right now she's at 46.4, yes?
Yeah.
And so the idea that, yes, that is where your null hypothesis focuses around, except instead of saying equals on this one, because here's the deal, will her percentage always be 46.4? No. If we're just talking, the idea of the normal one, or your null hypothesis, is probably going to be 46.4 or less. Because what is the claim here for the alternative hypothesis? If the coach helps her, what should happen? She should increase her percent of saves, right? And so, if I was debating, it might be easier on this particular one. And it doesn't matter which you find first. And I'm going to keep writing the words out so you can get used to them. Alternative hypothesis, but realize in Savas, you're just going to see H sub A, right? They're not going to write alternative. They're just going to say H sub A. And for this, I'm going to use P. And so what are they claiming in this problem? They're claiming that her percentage will increase if the coach helping or the coach changing her setup works. I sure can.
Thank you.
And so we're going to say P greater than 46.4. Okay? Now, the other one of that is the null hypothesis, which, what's the notation? H of O, right? H sub 0. And this one, we're going to start with P. And I totally see the whole equal to 46.4. But what we're going to look at this one is, it's not going to necessarily be at 46.4. If she's not improving, she's going to be probably 46.4 or less. So I'm going to say P less than or equal to 46.4. Now, what I will say on that is if you can pick out one of these, you are usually able to find the pair in the homework. Okay, that was my success. If I was a little hesitant of what they wanted for the other one, if I could pick out that, okay, the alternative hypothesis is going to be greater than 46.4, I was usually able to pick out the correct pair. Okay? Trust me, I get it. There's definitely a learning curve here, isn't there? I know I haven't taught this type of lesson before, and I know you guys probably haven't seen this type of stuff before, because I do feel like it's a newer aspect of the standards. So, are we okay with the idea here? And again, and I'm trying to take you through several different examples so you can kind of see what you're going to see in the homework. Okay? Okay, we're going to go back and talk about the gas mileage again. Okay? A car company performed an experiment to determine whether the fuel additive from the previous example increases a particular type of car's gas mileage. The company recorded the gas mileage of 10 identical cars, all driven under the same conditions, with and without the use of the fuel additive. Okay? And then the question is, how can you use the data to compare the effectiveness of the additive? Okay, so working towards the idea of how do we prove or disprove one of our hypotheses. In other words, we would need to approve one and reject the other, I think is the word they use. So, 10 pieces of information. 5 of these cars were without additive, and there's their gas mileages. 5 of them were with additive, and then there's their gas mileages. How can we compare that information? What could we find? Can we take these 5 without the additive and find the average? take these 5 with the additive and find their average. Okay. That's what I want to do here is I want to find both averages, and then we're going to work with our hypotheses here. We're going to have hypotheses based on the 2 groups. So, if you would, we're going to find our mean without the additive. I just wrote addition. Try that again. Additive. And we're going to find our mean with the additive. And for something to represent these as, I'm going to call without the additive group 1. I'm going to call with the additive group 2. That way I can find mean 1 and mean 2. Or mu1 and mu2 is what I just wrote. You guys are going to do the math, right? Right? Grab the calculators, do some calculating. Let me know when you get some information about group 1. What are you finding out about group 1? $34.56. They added up, the 5 values added up to be 172.8. You divide that by 5. We end up with 34.56. What about the group of 5 with the additive? Okay, 35.32. They added up to be 176.6. Dividing by 5, you end up with 35.32. Okay. As you look at these 2 values, okay, and we start to compare them, what do you notice? They're what?
The mean with the group with the additive is higher.
Okay. The group with the additive, the mean with the additive is a little bit higher. Is it a lot higher or a little higher? A little higher, right? Okay. What would you expect here? If the additive is doing its job and showing a big increase, what would you expect to be true about the means? They're going to be farther apart, more different maybe, right? That one with the additive should be increasingly higher. What about if the additive isn't doing anything? If the additive is not really doing anything, what would you expect to be true about these 2 means? What'd you say? They wouldn't differ much. In fact, they could even be the same. Excuse me. So, let's start with the idea if the additive is not doing its job. In other words, let's think about a null hypothesis. Okay. Remember, the null hypothesis is just by chance. Okay. No outside effect, just by chance. And so if we talk about the null hypothesis, the idea, our brains want to say that U1 would equal U2, yes? That's what my brain logically says. Now, what are we going to say? What's going to be true then if you subtract them? If they're the same, it'd be 0, right? So I know the null hypothesis here was written as u of 2 minus mu or u1 equals 0. The idea that the difference between the two would be 0. Or the closer the difference between the two gets to 0, the less the additive is doing. It's more just by outside chance. So that's your null hypothesis. Alternative, well, again, what's the claim we keep talking about? For the alternative hypothesis, the claim is that what? The one with the additive is higher. Now, again, if it helps you, my brain would say that group 2 is bigger than group 1, yes? That's the easy part in my brain. Is that okay, it makes sense if I say group 2 is greater than group 1. So the mean of group 2 is bigger than the mean of group 1. How can we put that as more of a statement? U2 minus U1 would be what? Bigger than 0? I guess what I would suggest is kind of think of it as solving an equation. Okay? The idea that if you have the average of group 2 and we subtract the average of group 1 over, it's going to be greater than 0. Those are the hypotheses we can kind of work if we're looking at two groups and trying to decide additive versus not additive, is it working? So null hypothesis, you subtract them, you get 0. In other words, they're about the same. Alternative hypothesis, you subtract them, you get a value greater than 0, indicating the additive is working. What is our difference here when we subtract ours? We do the average of group 2 minus the average of group 1. What are we getting? You do that 35.32, subtract 34.56, you're getting 0.76, right? Now, what does that indicate to you? Okay. The additive might be doing a little, but not necessarily much, right? So what it comes down to, that's kind of a borderline situation. So is this 7600's difference, is this due to the additive, or is it just random variation? I'm trying to use that, yeah, that's what I use here. So that, how the book say, if say natural variability, right? What is it due to? So that's the question we have to consider as we move forward. Is this due to the additive or random variation? Think about what we've been doing the past week. One sample isn't enough, right? So what's going to be the idea then? It's hard to just look at one group. It's better to look at multiple groups. And that's the direction we're going to take next, is that one way to test the hypothesis is to randomly assign the data to two new groups many times and look at the variability of the differences of the means. Okay? Now, if the additive is making a difference, we should have differences between our two groups no matter how you organize it. Okay? If the additive is not doing its job, then these groups are going to be close together. And so if we look at our two groups here, okay, This table, there's one set, 2 new groups already assigned. So let's check these out. If you will, find your averages. The average of group 1, the new group 1 if I should say, and the average of group 2. What are we getting for the average of group 1? What was it?
34.
Okay, 34.9. The math you would have been doing was 174.5 divided by 5. What about the second group? We get 34.98. 174.9 divided by 5. What is the difference between these two? If you subtract the average of group 2 minus the average of group 1, okay, 0.08, 800ths, right? What is that saying? Okay, additive's not doing much. Okay, so if there's no difference in the groups with and without the additive, then the differences between the groups will be closer to 0. So I'm going to write a statement here so I have that information down. There's no difference between additive or no additive. The difference will be 0. Now, do I have time? Okay. I guess we're stopping there, aren't we? In my morning class, I got through the next example, which was really a little bit better stopping place. Kind of an awkward stopping place for us, but that's all right. We will continue on Monday, and we will continue talking about the different hypotheses and go from there.